Most people hear moon mission and think, cool, but what does that have to do with me? You still have bills to pay. You still have school, work, groceries, rent, gas, taxes, and 100 other things on your mind. So when NASA talks about going back to the moon, it is easy to think this is just a big, expensive science project. Something exciting for astronauts, engineers, and space nerds, but not something that changes your daily life. But that is the wrong way to look at Artemis. The Artemis Moon missions are not just about planting another flag on the moon. Apollo already proved humans could get there. Artemis is about something much bigger, building the system that lets humans keep going back. That difference matters. Apollo was like proving you could cross the ocean once. Artemis is about building the ports, ships, supply chains, maps, rules, and jobs that make crossing the ocean normal. And when something impossible starts becoming normal, it does not just change space. It changes Earth. Artemis is NASA's long-term Moon to Mars program. The basic idea is to use the moon as the next training ground for human civilization beyond Earth. First, learn how to send people farther than low Earth orbit. Then learn how to keep them alive. Then learn how to land, work, drive, communicate, generate power, build infrastructure, use local resources, and eventually prepare for Mars. That sounds far away, but parts of it are already happening. Artemis I launched in November 2022 without a crew. It tested NASA's Giant Space Launch System rocket and the Orion spacecraft. Orion went around the moon, came back to Earth, and proved that the basic deep space system could work. Then Artemis II took the next major step. It sent astronauts around the moon for the first crewed lunar mission in more than 50 years. That mission was not about landing. It was about proving humans could safely travel around the moon again using this new generation of spacecraft. Now the program is moving into a more complicated phase. Artemis III is planned as a major test mission in Earth orbit. Instead of rushing straight to a landing, NASA's updated plan is to test critical pieces first: Orion, life support, communications, docking, spacesuits, and commercial lunar landers from companies like SpaceX and Blue Origin. That may sound less exciting than a landing, but it is actually smart. If you are going to send humans to the surface of the moon, you do not want to discover a docking problem, a software problem, a suit problem, or a lander problem when astronauts are already 250,000 miles away from home. Artemis IV is now the mission NASA is targeting for the first renewed crewed landing near the lunar South Pole. And the South Pole is important. This is not just because it sounds cool. The lunar South Pole may contain water ice in permanently shadowed craters. Water matters because it can support life, but also because water can be split into hydrogen and oxygen, which can become rocket fuel. That means the moon may not just be a destination. It could become a refueling point, a science base, and a testing ground for deeper space exploration. Now here is where this connects back to you. The first impact is jobs. When people think of NASA, they picture astronauts. But astronauts are only the visible tip of the iceberg. Behind every mission are engineers, welders, software developers, manufacturers, logistics teams, scientists, designers, project managers, data analysts, robotics specialists, communications experts, medical researchers, contractors, suppliers, and small businesses. A moon mission is not one rocket. It is an entire economy. NASA's Moon to Mars activities have already generated billions in economic output and supported tens of thousands of jobs. And this is not limited to one city or one launch site. The supply chain stretches across states, companies, universities, labs, and international partners. So when you see a rocket launch, do not just think, there goes NASA. Think, there goes years of manufacturing, coding, testing, contracts, training, construction, research, and payroll. The second impact is technology. A lot of the technology we use today came from solving hard problems in extreme environments. Space does that better than almost anything else. When you have to keep humans alive in deep space, every system has to become smaller, lighter, smarter, stronger, and more reliable. That pressure creates innovation. Better water filtration, better medical monitoring, better materials, better sensors, better robotics, better batteries, better communication systems, better software, better emergency systems, NASA's spin-off program has already documented more than 2,000 commercial technologies connected to space research and NASA work. That does not mean every gadget in your house came directly from a moon mission. But it does mean space exploration creates a pipeline of technology that often finds its way back into medicine, transportation, safety, manufacturing, energy, and consumer products. Artemis is pushing that pipeline again. Think about lunar spacesuits. They have to protect humans from extreme temperature swings, radiation, sharp lunar dust, and the vacuum of space, while still letting astronauts move, bend, collect samples, and do real work. Think about lunar rovers. They have to drive across rough terrain where there are no roads, no repair shops, no gas stations, and no easy rescue. Think about communications. Artemis needs to send video, voice, data, commands, and science information across lunar distances. Those problems are hard. And when humans solve hard problems, the benefits rarely stay in one place. The third impact is science. The moon is like a time capsule. Earth is constantly changing. Wind, water, weather, volcanoes, plate tectonics, and life itself have erased or transformed much of our planet's early history. The moon is different. Its surface preserves clues from billions of years ago. By studying lunar rocks, craters, ice, dust, and terrain, scientists can learn more about the early solar system, the history of impacts, the origin of the moon, and even the conditions that shaped Earth. The moon may also become a powerful platform for astronomy. The far side of the moon is shielded from much of Earth's radio noise. That makes it one of the best places to imagine future radio telescopes that could look deeper into the universe. So Artemis is not only about going to the moon. It is about using the moon as a laboratory, an archive, and possibly an observatory. The fourth impact is global politics. This part does not get enough attention. When more countries and companies start operating near the moon, space needs rules. Who gets to land where? How do you avoid interfering with another mission? What happens if one country places equipment near a valuable resource? How do you protect historic sites like the Apollo landing areas? What counts as responsible use of lunar resources? What happens if debris damages another mission? These questions sound futuristic, but they are not. They are the space version of shipping lanes, air traffic control, mining rights, environmental rules, and international agreements. That is why the Artemis Accords matter. They are an attempt to create shared principles for peaceful exploration, transparency, emergency assistance, scientific cooperation, resource use, and avoiding conflict in space. In plain English, Artemis is not just building rockets. It is helping write the rulebook for the next era of human activity beyond Earth. But we also need to be honest. Artemis is expensive. It is complicated. It has delays. It depends on many moving parts, including government agencies, private companies, international partners, rockets, landers, spacesuits, software, supply chains, and political support. If one major system is late, the whole timeline can shift. There are also ethical questions. Should we spend this much on space when there are problems on Earth? Who benefits from the new space economy? How do we protect scientifically valuable lunar sites? How do we stop the moon from becoming a messy, polluted, competitive land grab? These are fair questions. But the answer is not to ignore space. The answer is to shape it properly. Because humanity is going there either way. The real question is whether we go with good rules, shared benefits, scientific purpose, and public accountability, or whether we let the future be shaped only by whoever moves fastest. So what does Artemis mean for you? It means the next generation of jobs will not only be in traditional fields. They will be in robotics, aerospace, artificial intelligence, materials science, advanced manufacturing, communications, energy systems, geology, medicine, law, policy, and logistics. It means the skills that matter on the moon may also matter on Earth. Problem solving, systems thinking, engineering, coding, research, planning, risk management, and international cooperation. It means the technologies built for survival in space may improve life here. It means the moon could become the testing ground for how humans expand without repeating the worst mistakes we made on Earth. And it means that space is no longer just something you watch in documentaries. It is becoming an industry, a policy issue, a science frontier, and a career path. The Artemis missions are not just about astronauts walking on the moon. They are about building the first real bridge between Earth and deep space. And whether you become an engineer, a student, a business owner, a voter, a scientist, a teacher, or just someone trying to understand where the world is going, this matters. Because the moon missions are not only about where humanity is going next. They are about what kind of future we are building while we get there.